Hi, everyone. We are going to get started at about 12:03 p.m. Eastern, so about 5 minutes from now. So if you want to go get a cup of coffee or a drink of water, you can. And I'll also put this in the chat. Okay, we're going to go ahead and get started. So thank you everyone for joining us today. We're really excited about this topic. My name is Jennifer Gill, and I'm the VP of Product Marketing here at Skyhawk Security. And I'm joined by Amir Shachar, who's our Director of Data Science and Security Research. So Amir, thank you for joining me today.
Great to be here, Jen.
Great. So we're going to learn about how you can prevent cloud breaches with Skyhawk Synthesis and Chat-GPT. Okay, so here's our agenda for today. We'll do a quick introduction on speakers, the issues that we see, what is Skyhawk Synthesis, and how we use Chat-GPT to prevent breaches, and then we do have time for questions. Okay, so first I mentioned Amir Shachar. So he's our Director of Data Science and Security Research. He has over 15 years in technology leadership positions. He's the author of Semi-Discrete Calculus and has 5 years experience in leading artificial intelligence, machine learning, and data science teams. And then my name is Jennifer Gill. I have over 20 years of high-tech product marketing experience, which I can't believe I can say over 20 years, but I can. And I've had various leadership positions at Zerto, Commvault, and Pegasystems, and now Skyhawk. So some of the issues that we see in the market are, we hear from our clients, from prospects, from analysts, that there are just too many alerts. And we know that when everything is alert, that means nothing is an alert. We've learned that not all misconfigurations can be fixed. Actually, on another webinar that I did, we mentioned that by 2026, about 50% of attack surfaces won't be able to be patched. So you have to find another way to manage those. Coordinating data from multiple security tools is complex and error prone, and multiple security tools leads to inconsistent security. And we actually have a quick poll for you on this, and I'd love to see which one of these resonates more with you. The too many alerts, I can't fix some of my misconfigurations, those sort of things. And we will leave it open for just about 30 seconds. Not surprised to see too many alerts coming through. That's something we hear a lot. So let's give it a couple more seconds. Interesting that no one has yet selected, I can't fix some of my misconfigurations. It's kind of interesting. One of the things that actually comes up with that is we hear from clients, yeah, we fixed something, we patched it, and then the DevOps team starts messaging us that they can't do their work. So I'll close the poll. Thank you. Too many alerts, the clear winner by far, not surprised. Thank you so much. Okay. So with that, we'd like to introduce the Skyhawk Synthesis security platform. So this is a platform that includes risk management capabilities, so things like posture management, permissions hardening, and things like that, but also includes runtime observability, and that's where we really prevent threats and breaches in the environment. And we support all the major clouds and Kubernetes. Okay. So we like to use an analogy to kind of simplify the way that we think things around security, because some of it is just, it's so complicated. So if you think about your house, you have doors and windows, you want to make sure you close all the doors and windows, and you want to make sure that they're locked. This is essentially CSPM. So you want to make sure you kind of lock down your perimeter, removed as much risk as you can. However, we know that even when you lock your doors and windows, you still can be, you still can have a burglar or a threat actor in your environment. And that's the same thing with a cloud. So we have this sneaky threat actor who snuck down the chimney like Santa Claus. We see him go up the stairs. Now, maybe when he's in the living room, it's not as concerning for you. You don't want him there for sure, but you don't have things like your jewelry or your social security number or your tax information. But once he gets to the attic, we see that there's a safe there. That's where the valuables are. And that's when we see the alert. And that's what threat detection and breach prevention from Skyhawk Security does, is once the threat actor is in the area where you don't want them to be, we start to raise some concerns maybe when they're in the living room, but we definitely stop them before they get to your safe. Okay, over to Amir.
Thanks, Jen. So just to simplify the way our system works, so essentially what we do is we monitor each of the users' data via the AWS or other providers' logs, and then we build a model for each of the observed users, and from the model we deduce what is the normal behavior and what is the abnormal behavior. And we also have rules that help us decide what kind of abnormal behavior can be considered malicious. We call these machine learning based rules malicious behavior indicators, or MBIs, which is like the first layer of machine learning that we're using. And then on top of that, we kind of correlate the different MBIs into an attack story that tells really the whole story of what really went bad or suspicious in the events that took place. And then we, after building this sequence, we also rank it or score it in terms of maliciousness level with another type of machine learning algorithm. And then in turn, once we have the attack story scored, we suggest either automatic or semi-automatic ways or responses for mitigation of the threats.
Great, thanks, Amir. And you'll see this over the next couple of slides. We're going to go into more detail on exactly how this works and how we sort through the information and only bubble up things that are actually alerts. And since that was kind of the top vote getter, that's what we'll focus on for the webinar. But we do, of course, help you manage unpatchable attack surfaces as well. Okay, so how this works. So first we start with many data sources and telemetry, and we like to consider ourselves kind of the hub of log information and just behavioral information and things that are happening within the environment. So we pull those all into the platform and then start to analyze them. And then Amir is way better at the machine learning aspect, so he will talk about that.
Thanks, Jen. So the classical machine learning concept we're using is, first of all, we will clean and aggregate the data, enrich it with some kind of third-party data, and then we aggregate everything into a model via the MBIs, which in turn outputs how anomalous and malicious we think this specific event is. And then, in turn, if we move to a visualization of what happens, so we essentially look into the data, we extract these different MBIs from the data points, so we can see that we have, based on the logs that we gather, maybe a couple of MBIs. And then the next step would be correlating them via a sequence of events. So for example, here we see that there was an anomalous AWS usage activity followed by unusual activity time and so on. And then this sequence of event gets scored with another type of machine learning algorithm.
Yeah, and Amir, I think it's important to talk about, so we have different layers where we do machine learning, and one of them is the threshold. So because we don't want to send you thousands of alerts for you to act upon, because again, when everything's an alert, then nothing is. So this is something that we look at across all the environments that we're monitoring to look at see how threat actor's intent is in someone else's cloud and see if that's relevant to your cloud. So then we use all that data and aggregate it to get to the scoring mechanism. So it's not just based on one cloud for that score. And we're looking across many, many, many clouds to be like, okay, now this is an alert.
Exactly. And it's updated dynamically, and it's a very dynamic threshold. Yeah, so once we have this sequence of events, so up until now, we only spoke about like traditional machine learning algorithm that we have been using. And now let's see how we can leverage ChatGPT, or how it can help us in this process. So in the traditional framework, we might have alerted at a specific time point, but with by applying ChatGPT, we may be able to alert a lot earlier, meaning we can increase the confidence of our system to alert even in cases the classical machine learning algorithms are not as confident. This helps us reduce the false positive that all of you mentioned, or many of you mentioned, and also false negatives. And in turn, it allows us to alert a lot earlier with respect to what we would have alerted without ChatGPT. And this allows our clients to allocate less resources for the analysis of security alerts and increase the confidence. Yeah, so now we saw what's the motivation of using ChatGPT. Let's talk a little bit about how we actually do it. So we call it collective intelligence-driven second opinion. And it turns out that one can actually prompt ChatGPT to rank a sequence of events or a log or a set of logs in terms of maliciousness level. But if we do it several times, we might get different results because of the statistical nature you're all familiar with of large language models. And to overcome this, we may consider consulting with different large language model-based agents. So for example, if we prompt a given instance of ChatGPT with a sequence of events, we might get the following answer.
Hi, my name is Scott. I would score the sequence as 7 out of 10 in terms of maliciousness because a combination of events in it is suspicious, but other events make it look more benign in my view.
And then when we ask another agent to score it, we get the following.
Hi, my name is Hawk. I would score it as 8 out of 10 because this combination of events is much more suspicious in my view, and I don't think that the events Sky pointed out make it look more benign.
So both of these agents' answers make sense. They're both relying on some reliable sources, but they come up with different conclusions. So what we could do, and what we actually do, is we ask several or thousands of different agents how would they score this given sequence. And then what we can do is we can put it all into a distribution of the votes where we know for each score how many agents voted. And in turn, this distribution helps us come up with, for example, the median of the distribution and the variance, and build a confidence interval, which helps us be more confident about about the decision of whether we want to promote this alert or this incident to human researchers. And this is, of course, only one way we could combine the votes. There are many other ways. For example, we could let the agents speak with each other, but that's just to get a feeling.
Yeah, and I think this is what really hones in on what we're trying to do, is we're trying to prevent many false positives and false negatives and get to this is really the issue.
Exactly. Now, so we saw what's the motivation, we saw how we actually do it. Now let's talk a little bit about a major problem that the large language model have, which is that they support only a very limited context. For example, GPT-4 only supports up to 32K tokens, and the logs that describe the activities of the users might be much longer. So how can we actually, in practice, implement it? So we could apply some workarounds, but before we talk about the workarounds, let's talk about the future. So it looks like, and this is a recent paper, it looks like in the not very far away future, it will be possible to use almost unbounded context, or for this matter, a large enough context for us to query a given story of an incident. But yet this is not yet fully available, and also it might be a little bit expensive. So in the meanwhile, until we get a better solution, what we could do is apply the following workarounds. So for example, we could segment the logs into smaller chunks based on time frame or activities and so on. We can store the summary of each of the segments and the ICE, potentially do it incrementally, and then eventually score the summary of the summaries. So that's one approach. And we could also take it to the next level and use a vector database such as Pinecone, where we could store some kind of summary of, let's say, a daily summary of each user's logs. And then upon viewing a new daily summary, we could compare it with the existing summaries in the database. And this allows us, because of the nature of the vector database, this allows us very rapid anomaly detection, which helps us correlate the behavior in this day to previous days.
Okay, great. Thank you, Amir. So I think you see how we're using ChatGPT to more accurately present incidences to you before they become breaches. But there's another way we're using ChatGPT, and that's to improve the accessibility of security information. So you can see here we have an alert, and you get a summary of the alert. So what's happening here? You get a full explanation of the storyline and some remediation suggestions. So if you have a little bit more of a junior security team, this is a way to kind of augment that team so that they can get more experience and they get a little bit more information. And we are using ChatGPT, but we're also using other large language modeling as well. But this is just the two ways we're kind of integrating ChatGPT to start, and I'm sure there are more opportunities. So, and then I wanted to just point this out because I think other organizations talk about path analysis and things like that. And it's kind of the hypothetical, like, hey, this could potentially happen in the environment. They just want to make sure it's very clear that what Skyhawk is presenting to you is what is actually happening in the environment. So you can see these are the anomalous activities and malicious behaviors that we're seeing someone execute again and again and again to try to get to your crown jewels. So this isn't, hey, this maybe might be happening. This is no, there are no maybes, might, potentially. This is what's happening in the environment if you see it from Skyhawk, and this is why action is required as soon as possible. And then before we jump into questions, and if you want to put questions in, please use the chat feature. So we saw a couple come in already, which is great. So here are just a few ways we can help you. So the first, eliminate alert fatigue with attack sequences. And I think we've talked a lot about that. It's good that this resonates with all of you, that you're seeing too many alerts. So that's something that we want to help you prevent. We want you to react to things that require a reaction, not waste your time with someone who maybe clicked on the wrong thing and then you spent 3 hours looking at it and it turns out some marketing person, because it's always the marketing person, clicked on something they weren't supposed to, and then it's like, oh God, this was fine. So that's one thing. We also want to layer on threat detection on top of CSPN and KIM. Like, you know, you lock your doors and windows, but people still get into your house. So how can you find that person there and prevent them from getting any further into your environment? Improving the accessibility of security information to improve productivity. And we can reduce the time it takes to detect a breach. So we have seen some go as long as 207 days in an environment without any realization. And then lastly, we improve productivity with a single platform for the 3 major clouds as well as Kubernetes. So now when someone goes in to look at an attack sequence, whether it's in Azure, AWS, or Google, they're going to have the same information and they're going to know how to use the product or the platform to remediate the situation. So that consistency is going to improve the productivity overall of your security team. So thank you so much for joining us today. We're happy to take any questions you might have. I just need to get over to the chat. Okay. Oh, there we go, Q&A. Okay, perfect. So you can use, sorry, I said chat, sorry. Use the Q&A function to please type in any questions. And we did have a couple come through already. So the first one says, many organizations say they use artificial intelligence and machine learning. What makes yours different? And I hear this a lot, especially when talking with analysts, because everyone says, oh, we're using AI, we're using ML, you know, we're doing these things. I think what makes ours different is first that we're doing models at several different layers within the environment. So we do models across all the customer clouds. We model things within the customer cloud, like network behavior, and then also at the individual asset level. So we're looking at things like what's the typical API usage for this particular person? What's the typical API usage for this role? And so by building all those models, we get very granular, and this is how we develop the MBIs. And Amir mentioned that they're updated automatically. The data science team looks at these daily across all the models and makes updates if they are measuring drift in the model. So it's amazing. Every time I meet with the data science team every other week, and every time I talk to them, it's just amazing to hear all the cool things that they do. So Amir, anything to add?
Yeah, I mean, you covered, you said it very well. We have many cool things coming up.
Yeah. Okay. So a question that came in is, do you support GCP already, or is it in the roadmap? So it's on the roadmap, it's in development, and we expect to have at the end of this quarter. So that's the goal. Okay, and then another question that came in, and Amir, I'm going to need you to answer this one all alone. So it's, can you mention some next generation evolutions of Chat-GPT in the context of cybersecurity?
Sure. So I actually mentioned one of them, which is models that whose context is not limited or less limited, which enables or which will enable to prompt ChatGPT or other large language models with much larger context, potentially with the entire story of a given user. And other evolution might be using things like AutoGPT, which is combining ChatGPT with different agents that speak to each other and can plan ahead. And this can be used in different contexts, both for attack and defense. I mean, I think these are the main things. Of course, that any advancement in the GPT series will make security much better. We saw a major improvement when switching between 3.5, and 4 when I talk about the versions of GPT.
Wow, great. Okay. And then another question that came in is, what are some of the challenges in implementing Chat-GPT for cybersecurity purposes?
Yeah, so again, I also spoke to that in terms of the context, the limited context. Some other challenges are, for example, security concerns, right? So you don't want to send over to ChatGPT PII, you want to anonymize data. And of course, we do that. And on top of that, it might get costly if you use it extensively. So you need to come up with maybe a proprietary large language model and so on. And also the runtime of the model might be a problem. So you may want to consider applying some kind of pre-processing, not to run it in real time. And you need to get hacky about it.
Yeah. Okay, that makes sense. So I'm trying to make sure we let everyone go at 12:30 because we try to like to finish just a little bit early. So I think we're going to close out the questions. We only missed one, so I will make sure to follow up with you directly. But don't worry, we will follow up. And I guess lastly, just thank you everyone for spending 30 minutes with us to learn about ChatGPT and how we're leveraging it at Skyhawk. You can see we do some really exciting things with large language models and machine learning and AI. And it's really, like I said, every time I talk with the data science team, I'm just continually impressed and blown away. And as a marketer, it makes my job, I won't say easy, but I will say better in that I always have something really cool to talk about with the product. So, and lastly, my really last thing, so thank you all for joining us. Amir, thank you for doing this webinar with me today. The recording will be available. And like I said, we'll make sure to follow up with that last person on the question. Thank you, everyone.